earlier, I was talking about in kinematics that it's applied forces. That's how things move, is a force is applied. Now, kinematics is actually made up of 3 different laws by Sir Isaac Newton. Sir Isaac Newton is a well-known scientist who lived in the 16th century. Actually a professor at Cambridge University in England. His first law is the law of inertia. Inertia is a word that means that things that are in motion will stay in motion unless another force is applied on it. That actually comes from a word used by Galileo, who was his idol, I guess. A lot of you guys probably know about Galileo Galilei for astronomy. So his first law is inertia. His second one is the most common one, which is F equals ma, which means that the net force on an object is equal to its mass times its acceleration. So here's an example. This originally is how to draw an FBD, as you guys probably know, as a free body diagram. So in this question, we had a couple of people trying to push a car because I guess it got stuck or something, and they were pushing with a force of 275 newtons. And the force that the car applied on the people was 560 newtons in the reverse direction, and the weight of the car was 390 newtons. So here's my free body diagram. As you can see, 275 newtons is being applied to the right. That is the force of the people pushing on the car, and a 395 newton force going in the same direction, because that's the weight of the car. The 560 newtons is going in the reverse direction because the car is also pushing back on the people who are pushing the car. And that leads us to Newton's third law, which is that when you push something, that object will push back at you with an equal and opposite force as the one you applied on it. For example, if I push on a wall, the reason the wall doesn't break down is because it's pushing the same amount of force back at me, and so it balances out. That's also why the wall doesn't move when I push on it. If I had pushed with a greater force and the wall pushed back at me, then the wall would have moved. Now, the first thing that you want to do before you can apply the second law is to figure out what your net force is, which means the sum of all your forces, keeping into account your forward and backwards, which will determine your plus and minuses. So in this situation, I have 275 newtons being pushed in the positive direction, 395 newtons being pushed in the same direction, but a 560 going in the opposite direction. This is why it's negative. When I add all these numbers up, I get a total of 110, which is positive. Now I want to figure out what my acceleration is. The question itself said that the mass of the car is 1,850 kilograms. So the acceleration would be my net force divided by my mass, which would be 110 divided by 1850, which gives me 0.059 meters per second squared in the positive direction, since my final number is positive. If that was a negative 0.059, then that would mean that it was going in the opposite direction, and it would also mean that the car is actually pushing the people back instead of the people pushing the car forward. And so that wraps it up for forces, and I'll see you guys next week. Subscribe to me so you guys can see some cool videos doing science and experiments and maybe learning something new. Thanks!